Here is a fact most engineers do not know. Cassandra and DynamoDB are siblings. In 2007, Amazon published a paper called Dynamo, describing the internal system that kept Amazon shopping carts alive even when machines failed or networks split apart. The paper was not famous because of theory. It was famous because it solved a brutal business problem. The cart could not go down. That paper introduced a few core ideas. Spread data across many machines instead of relying on one giant server. Keep multiple copies of data so failures do not destroy anything. Avoid a single master machine becoming a bottleneck. And allow systems to trade perfect consistency for speed and availability when necessary. Then, the family split. Facebook engineers took those ideas, mixed in concepts from Google Bigtable, and built Cassandra as open-source software. Amazon took the same distributed systems DNA and turned it into DynamoDB, a managed cloud service inside AWS. Same ancestry, completely different philosophy. The easiest way to understand the trade-off is to watch a startup grow. On day one, there are 5 engineers building a delivery app on AWS. They do not want to manage clusters. They do not want PagerDuty. Traffic is unpredictable. Some days are quiet. Weekends explode. For this team, DynamoDB feels magical. You create a table and immediately start writing data. AWS handles replication, failures, scaling, backups, and upgrades. Reads come back in single-digit milliseconds. Pricing is request-based, so when traffic is low, the bill stays tiny. When traffic spikes, the database stretches automatically. Now, fast forward 5 years. The startup succeeded. It handles billions of requests every day across multiple continents. Suddenly, the economics look different. That convenient pay-per-request pricing now produces an enormous monthly bill, because at huge sustained scale, paying rent on every single database operation becomes expensive. And the company now has infrastructure engineers who actually want control over topology, consistency, and hardware costs. This is when teams start looking at Cassandra.
Cassandra is not a service you rent. It is software you operate yourself. You run it on your own machines, your own cloud accounts, or across multiple clouds entirely. Its architecture is a ring of equal nodes with no central master. Data is partitioned across the cluster and replicated across machines and even regions. The important operational idea is simple. Add more nodes and throughput grows with it. At large sustained workloads, the cost per request can fall dramatically because you own the machinery instead of renting every operation from a cloud provider. And that leads to the real deciding question. Do you want to rent the database or own it? Renting means DynamoDB. You get convenience, automatic scaling, tight AWS integration, and almost no operational burden. It is perfect for small teams, fast-moving startups, and workloads with unpredictable traffic. Owning means Cassandra. You get portability, tunable consistency, infrastructure control, and potentially much better economics at extreme scale. But you also inherit operational responsibility. You need people who understand partition keys, repairs, compaction, monitoring, and distributed systems failures. Neither option is free. They just charge you differently. And both systems have sharp edges. DynamoDB limits item size to 400 kilobytes. Queries revolve around keys and indexes, not flexible relational exploration. Migrating away from AWS later can be painful. Cassandra also demands careful schema design. A bad partition key can destroy performance. Running clusters well requires expertise, unless you pay for a managed Cassandra platform that softens the operational burden. And there is one more important point. Do not choose either database because you think distributed automatically means better. Cassandra and DynamoDB are both key-focused databases built for scale and availability. If your application needs rich joins, complicated relational queries, or heavy transactional workflows, PostgreSQL or another relational database may still be the better answer.